Welcome back to Digital Replay. We're starting Unit 9 today. This is pages 660 to 663 and 679 to 682 in your textbook. We're looking at Earth's structure. What does it look like on the inside? Like onions and ogres, Earth has layers. Lots of different layers that all have different properties. And we're going to divide this and conquer it and talk about the 4 different layers of the Earth. The crust, the mantle, the outer core, and the inner core. Sometimes the outer core and inner core is just called the core. And I have this picture of an egg here because if we look at the egg, it's got the crust or the shell on the outside. And then it's got the mantle, the white part on the inside. And then in the very center, the core of the egg, that's the yolk. That's kind of like the Earth, right? It's got the shell, and the thickness of the shell is similar to the thickness of the crust. I mean, if you have it scaled down, but it's not exactly perfect. So we're going to do a diagram today in this video, and in class we did a diagram where you take a page in your notebook and you make that page is going to be a cross section of the Earth, okay? And it's going to go from the surface of the Earth, which is at the top of the page, all the way into the very center of the Earth, which is at the bottom of the page. And I'm going to show you how to do that in this video, and I showed you how in class. So get out a piece of paper, follow along with me. Here we go. We're going to start with the crust. So the crust is very, very, very thin compared to the rest of the layers in the Earth. It's like the skin of an apple. It's super, super thin. In the oceans, it's somewhere between 6 and 8 kilometers thick. Very, very thin. And under the continents, it's like 30 to 32 kilometers thick. Much thicker, but still really thin compared to these other layers. So the crust is the outer part of the Earth's surface. It includes everything underneath the water in the oceans, all the way to the highest mountain. It's composed mainly of granite and basalt, and the continental crust is mostly granite and some andesite, and then the oceanic crust is basalt. Okay. And basalt is much more dense than granite, and because of this, the less dense continents tend to ride on the more dense oceanic plates. So if you have this collision between continent and ocean, continent's gonna go up and ocean's gonna go down, just based on density. Start with a blank sheet of paper, and on this piece of paper, from the top of the page, you're going to draw 2 lines. You're going to draw one line that's 1.25 millimeters from the top of the page, and a second line that's 4.3 millimeters from the top of the page. It'll look like this. 2 tiny, teeny lines from the top of the page. This represents your crust, so you can color it in some color. I colored it gray here. And your crust, you want to put some info about your crust. So do some kind of call out something down below it. Say the crust has a thickness of about 30 kilometers. It varies. The temperature is from 0 degrees Celsius and up. It has a density of 2.2 to 2.9 grams per cubic centimeter. And it's composed mostly of andesite and basalt, and some granite too. So that's your crust. So that's to the first line. The second line represents the bottom of the lithosphere. And I'm going to talk about the lithosphere here in a minute. So the lithosphere and the crust. Now I mentioned the lithosphere here in the diagram, and the lithosphere is the upper part of the mantle and the crust, or the upper rigid part of the mantle and the crust. And this part of the Earth is actually broken up into plates, and these plates tend to float on the convecting mantle. Now they don't really float, they just move around. So as the gooey molten mantle is convecting, it's going to push those plates around on the surface, and they're going to bump into each other and interact with one another. To really demonstrate the lithosphere, I gave you an orange to peel and then put back together. So then when I had you put these back together, we were able to see the different kinds of plate boundaries. A divergent boundary, where the plates are moving apart or moving away from one another. A convergent boundary, where the plates are sort of overlapping or one's moving underneath another. They're moving toward each other. And a transform boundary, where the plates are moving side by side. So how do the plates move? Well, I found this demonstration here about convection. And what we do is we take some colored water and we're going to heat it up nice and warm. And then we're going to place that hot colored water into a cool water bath. So now this is cold water. The warm air is going to rise or go up. The heated water rises, so that the warm water is moving upward. It's less dense. It's less dense than the cooler water around it. So it's going up. It flows out of this little chimney here. Now, this cool thing that we can do is we can take this. This is a great idea and everything. But how does convection work? Well, if there is a more dense or colder water, or if the heated water somehow cooled as it was going up and around, what you would start to see is you start to see motion downward. So as the heated water or the red water cools or becomes more dense, it's going to sink or go down. So this now becomes sort of a cycle, and you can actually watch this as the warm water starts to sink down to the bottom and then warm up again and go back up. This is convection. This is how convection works. So warm water is going to move up, and then as it cools, it's going to move back down. As it becomes more dense, it will move back down. These lithospheric plates moving and interacting with one another, this is a relatively new theory called plate tectonics. And I'm not going to go into it too much now because that's what the next video is for. We'll talk about Wegener and his theories of plate tectonics. But I did give you an assignment to sort of familiarize yourself with the plates. And I want to look at that right now. We'll just take a little segue for a minute and go look at that assignment. And I had you looking at a map of all of the plate boundaries and learning what are the different kinds of plate boundaries and what are the different plates on the surface of the Earth. So there's three different kinds of plate boundaries: divergent, convergent, and transform. Divergent is when the plates are moving away from one another, so they're moving apart. And convergent is when they're moving together, and sometimes one plate is going to go under another, sometimes they're going to crash, both go upwards. It depends on what kind of plates are crashing together. Are they oceanic plates? Are they continental plates? Or is it a mix? And then transform plates are plate boundaries are when the plates are moving side to side, so they're like slipping past one another or scraping past one another. And the map I had you look at was on the back of that assignment. I had you look at this map here and checking out all the different, here's the different kinds of plate zones, boundaries, and then looking at what is going on at each of the edges, and then naming each of these different plates. And then going kind of on a scavenger hunt to find these different plates here. So like this one, these two plates meet at the San Andreas Fault. That's number 3. So then I would look for the San Andreas Fault. There it is. And the two plates that meet there are the Pacific Plate, which is this big piece here, and the North American Plate, which is this piece here. So they meet there and slide past one another. So that was the assignment. That was a nice segue, but let's get back to our diagram that we're doing here. Earth's mantle is the next layer. Okay, so the next layer is Earth's mantle. This is the largest layer of the Earth, and it's very hot and dense, and it flows like asphalt. And this movement, like we were talking about, is the reason that the plates on Earth, that the lithospheric plates, are moving. So it flows because of these convection currents, like you saw in the little short video. And this hot material, it's warmed in the deepest part of the mantle. It rises and then it cools again as it falls, as it goes past the crust where it's cooler, or up in the upper mantle where it's cooler, and then it's going to fall again back toward the outer core, or toward the center of the Earth. And this just repeats. It just warms and cools and warms and cools. It's this nice cycle. The next line that you want to draw is 12.65 centimeters from the top of the page. So 12.65 centimeters from the top of the page, you're going to draw another line. This represents the lower boundary of your mantle. And you can give that a nice color too. I colored it red. And some information about the mantle. The mantle is about 2,885 kilometers thick. It ranges in temperature from 870 degrees C to somewhere around 3,000 degrees C. has a density of 3.4 to 5.6 grams per cubic centimeter, and it's made of lots of different stuff. Garnet, olivine, magnesium, and silicon oxides. So it's important that you include what it's made out of, because this is what helps distinguish these different layers. So just like we saw in that little video, when you see these convection currents, when they're going, warm is going up and cold is going down, this is also going to move whatever is on the surface of that convecting material. So in this case, it would be the lithosphere. It'd be the plates. They're going to get this like free ride on these currents, kind of like the cork in this illustration. Now the outer core is a ball of hot molten metals, and the outer core is so hot that everything's liquid, and it's composed mostly of nickel and iron, and it's hot. There's not a whole lot else to say about it. It's hot because it has iron in it. This and the inner core is the reason we have a magnetic field. It's hot down there. Now the next line you're going to draw is 22 centimeters from the top of the page. So 22 centimeters from the top of the page, you're going to draw a line. And this represents the lower boundary of your outer core. The outer core. So I gave the outer core a nice yellow color. So that's my outer core there. I'm going to write some information about the outer core. The outer core has a thickness of about 2,200, about 2,270 kilometers. Its temperature is from 3,700 degrees C and up. Density from 9.9 to 12.2 grams per cubic centimeter. And it's made of iron and oxygen, sulfur, and nickel alloys. Lastly, the inner core has temperatures that are so great that the metals in there are not liquid, but they should be. They're under intense pressure. So even though they're liquid, they're under so much pressure that they're more like a solid. The parts, the atoms in there are forced to vibrate in place. They cannot move around like a liquid normally does. They're just going to vibrate in place. And this vibration, this is what makes it kind of like a solid. It can't like move around or flow. Solids don't tend to flow. And so because it's like this, it's just sort of frozen in this spot. It can't really move, such intense heat and pressure, and super, super hot. That would be your outer core. Now the very bottom layer down here, this is your inner core. Okay, so this line down at the very bottom of the page, that would be the center of the Earth down there. So the very bottom of the page would be the center of the Earth, and this line here distinguishes the outer core from the inner core. And some information about the inner core: has a thickness of 1,216 kilometers, temperature between 4,300 and 7,200 degrees C. Density between 12.8 and 13.1 grams per centimeter cubed. Is made of the same stuff of the outer core: iron, oxygen, sulfur, and nickel alloys. And the difference between the outer core and the inner core is pressure. There's a lot more pressure on that inner core, so it's going to look a lot different. So there it is. If you were to shrink the Earth, the interior of the Earth, to the size of a piece of paper, there would be the relative thicknesses of all of the different layers of the Earth. So that means in that crust up here at the very tippy top of the page, the very first line that we drew, that 1.25 millimeters, in that very first line that we drew is everything from the top of the tallest mountain to the bottom of the deepest ocean in that first line, which is crazy to think about. Everything we know as the surface of the Earth is included in that 1.25 millimeters on this page. Wow. So that's that. Earth has four main layers: the crust, the mantle, the outer core, and the inner core. The lithosphere, which is the crust and the upper mantle, is broken into plates, and these plates move and interact because of mantle convection. That's been today's digital replay. If you have questions, comment below, send me an email, or see me in class. We'll see you next time.